Hello, my name is Liam Fraser and I'm a student in Bill Crothers Secondary School Advanced Functions 12 course. The purpose of my assignment is to create an instructional video that gives a thorough and detailed explanation of how to solve a problem. The problem that is assigned for this video is of the following. Page 371, question 9 of the Advanced Functions textbook. This particular question comes from Unit 4 in class, although Chapter 6 in the textbook. The reason why this question is from Unit 4 is because you are asked to find the instantaneous rates of change of a trigonomic function. We learned IROC in Unit 3, although that was for rational functions. Now, I will proceed to read the question, and following that, I will highlight key points of the question. Based off the information in the graph, Part A, determine an equation for the curve that models the ratio of mice per owl. Part B, use the curve to determine when the ratio of mice per owl has its fastest and slowest instantaneous rates of change. Part C, use the equation you determined in Part A to estimate the instantaneous rates of change in mice per owl when this rate is at its maximum. Use a centered interval of 1 month before to 1 month after the time when the instantaneous rates of change is at its maximum to make your estimate. Now, some key points to take note in before answering the question. Starting in Part A, this graph has a periodic relationship between the population of owl and mice. Due to this, we are going to use a sinusoidal function to model this. Sinusoidal functions repeat themselves in regular patterns, as does our graph. Part B, the fastest rate of change will occur when the graph is steepest. The slowest rate of change will occur at either the maximum or minimum when the slope is at 0. Part C, the way we can find the rate of change is by taking a point that forms before our interval and one that forms after the interval. It will also make it easier to choose the interval between your maximum and minimum on your x-axis. The plan that I will use in order to solve this question is of the following. Part A, find information about how long one cycle is, how much variation there is in population, and what the average population is. To get the information, I will use the data on the graph that is taken from the question. Now we will determine the different variables in the question in order to create an equation. The question asks to create an equation for the graph provided. It is important to determine which kind of function you'd like to use. Either a cosine or sine function will work, but be aware the sine function will also have a phase shift due to it not starting at its mid-value. In my question, I decided to use a cosine function because the function starts at its maximum and presented no phase shift. A general cosine function is y equals a cos b x minus h plus k. To begin solving the question, we will find the a value. Notice that this question will include an amplitude. The amplitude can be found by taking your maximum value on your x-axis, subtracting it by your minimum value, and dividing the difference by 2. The difference is divided by 2 to see how much the population varies, either below or above the middle. The maximum given in the question is 24.7, and the minimum given in the question is 15.7. Therefore, 24.7 minus 15.7 equals 9. 9 divided by 2 equals 4.5. Therefore, your amplitude and your a value will equal 4.5. Next, we will find the period of the function, which is the amount of time for a function to complete one cycle. A standard cosine curve has a period of 2 pi, but we will have to alter it in order for it to suit the circumstance of our question. The period can be seen visually by looking at the amount of time it takes for the function to go peak to peak. To find the period that will suit our question, you must take the standard cosine curve period and divide it by the period of the particular question. In our question, the period is 24 months. Therefore, b equals 2 pi over 24, so b is equal to pi over 12. The h value will represent a phase shift. Our h value will be 0 because, as I mentioned previously, with a cosine function that starts at its midway, it will not include a phase shift. Lastly, in order to find the k value, which represents your midline of the function or equation of axis, you need to add your maximum and minimum values and divide the sum by 2. K is equal to 24.7 plus 15.7. which is equal to 40.4. 40.4 divided by 2 is equal to 20.2. Therefore, our K value will equal 20.2. The equation that is produced through these transformations is 4.5 cos pi over 12x plus 20.2. Part B. Now, in Part B, we will be asked to use the curve to determine when the ratio of mice per owl has its fastest and slowest instantaneous rates of change. An instantaneous rate of change is defined as the rate of change at a particular moment. It can be solved by using the formula y2 minus y1 over x2 minus x1. To find the fastest rate of change on the graph, you are looking for when the slope is at its steepest. In order to solve this question, it will require a tangent line, which will allow us to find the slope of the graph. A tangent line is a line that runs very close to the graph, only touching it on one point. The tangent line that I will use in my question happens to go through 0 and 0, and also 16 to 20. The equation y2 minus y1 divided by x2 minus x1 will allow us to sub in our points and find the slope of our tangent line. 20 minus 0 over 16 minus 0 equals 20 over 16. 20 over 16 can be simplified to 5 over 4, and 5 over 4 as a decimal is 1.25. 1.25 will represent the rate of change for the fastest point of the mice per owl ratio. Next, in order to determine the slowest rate of change for the mice to owl ratio, the maximum and minimum will have a rate of change of 0, therefore making the slowest rate of change. The 2 points I will use in order to show the rate of change are 16.24, 32.24. Again, we'll have to use y2 minus y1 over x2 minus x1 to solve for the rate of change. 24 minus 24 over 32 minus 16 is equal to 0 over 16, which equals 0. Part C. The question is asking for me to use the equation that I previously made in Part A. Y equals 4.5 cos pi over 12x plus 20.2. Using this equation, I am asked to estimate the instantaneous rate of change at its maximum. I am then asked to use a centered interval of 1 month before and 1 month after the time when the instantaneous rate of change is at its maximum. The number of months that I have chosen to use is 16 because it is between the maximum and minimum on the x-axis. Therefore, the numbers that I must plug into my equation are 15 and 17 because I am asked to use 1 month before and after my centered interval of 16. On the graph, the blue dot represents my centered interval and the 2 yellow dots represent my 1 month before and 1 month after. After I find the solution to both x equals 15 and x equals 17, I must plug the values into y2 minus y1 over x2 minus x1 in order to estimate my final instantaneous rate of change. I will first use 15 to plug into my equation. Y equals 4.5 cos pi over 12x plus 20.2. Y equals 4.5 cos pi over 12 multiplied by 15 plus 20.2. Y equals 4.5 cos 15 pi over 12 plus 20.2. Y is equal to 4.5 cos times 3.9269 plus 20.2. Y is then equal to 17.0180. Next, I will input 17 into my original equation. Y is equal to 4.5 cos pi over 12 times 17 plus 20.2. Y equals 4.5 cos 17 pi over 12 plus 20.2. Y equals 4.5 cos times 4.45058 plus 20.2. Y is equal to 19.0353. With these solutions, I will now use the equation y2 minus y1 over x2 minus x1 in order to estimate my instantaneous rate of change. Therefore, my x1, y1, x2, y2 will be the following: 15 and 17.0180 and 17 and 19.0353. Therefore, 19.0353 minus 17.0181 divided by 17 minus 15 equals 2.017 divided by 2, which equals 1.008. This final unit of 1.008 represents the mice to owl ratio per month. This is 1.008 mice to 1 owl. My overall answers that I concluded with are of the following. Part A, y equals 4.5 cos pi over 12x plus 20.2. The fastest rate of change in part B was 1.25, and the slowest rate of change in part B was 0. In part C, the mice to owl ratio per month was 1.008. A career where this problem could be solved would be a wildlife biologist, because they have to monitor populations of predator and prey in order to secure the health of animal populations and the ecosystem as a whole.